Hello everyone, my name's Sean Williams. I am the founder and chief executive at AutoGen AI. I'm going to talk a little bit about large language models, which of course you will have all come across. But I'm going to talk about why I think they're so magical, why I think they're going to really genuinely change the world in the way that other technologies haven't since the internet. And I'm not a technologist, but I'm not entirely happy going on after two incredibly smart speakers. And unfortunately, now you've got me, and I'm not a scientist, I'm a philosopher, and I'm not a technologist, and I'm not clever, but I employ some super smart people, and they've helped me with my slides, so hopefully that will be good. So, I'm not a technologist, so I'm going to give you a historical thesis, not a technological one, about why I think large language models are so impressive and why they're going to change everything. But I'm going to start in 2700 BCE, and I'm going to start with the abacus. What does the abacus allow you to do? The abacus allows you to add up faster and multiply faster than you used to be able to do. So what? What does that mean? Well, it turns out if you can add up and multiply faster, you can trade faster. And if you can trade faster, you can do more complex trade. And trading with one another is a fundamentally human activity. So if you take something fundamentally human and speed it up by orders of magnitude, that is a technology which isn't just interesting, that's a technology that's going to change the world and change the way that human beings interact with one another and change society. Fast forward then to the printing press. The printing press speeds up the sharing of ideas. You don't have to write things on parchment with a quill anymore in order to be able to get ideas out there and share them. You can now share them fast with this new technology. And sharing ideas and persuading people of opinions and writing stories and all of those things that then go with being able to write and share the written word, that is fundamentally human, and the printing press by orders of magnitude speeds up that fundamentally human activity. The steam engine, of course, there's locomotion and moving around is fundamentally human, but there's manufacture, much more importantly. We are creatures that make things, and the steam engine allows us to make things much, much faster by orders of magnitude, and that transforms society. Electricity, similarly, radioactivity, similarly, and then in my lifetime, or at least the popularization of it in my lifetime, with the internet. And this, for me, really is the last technology which really transforms the way humans interact and the way we do business and the way we communicate and all of those things in society. And why does the internet do that? It's because it speeds up the sharing of knowledge and ideas in a way which hadn't been quite seen since the printing press. So then you've got these things, large language models, and in art and in music and in my space, in the written word, what do? They speed up the creation then of content, right? And creating content and then sharing content, that is a fundamentally human activity. So I'm going to suggest to you that in a way that lots of other technologies weren't going to change things, large language models are, and it's a historical thesis, not a technological one. This is a fundamentally human activity that we've now got a technology which speeds it up massively. So, Herb said I might just spend a couple of minutes talking about how I got into this. So I've had 3 careers. In my first career, I worked for big outsourcers on big projects on behalf of governments. And then I got very, very bored of the corporate world and left. And I don't need to explain why to anyone who's ever worked in the corporate world. My second career, I founded and set up a management and technology training company called Corndell, which I set up in September 2016, sold in September 2020, and then left in September 2021. And I retired. I retired for 3 weeks, the most boring 3 weeks of my life. And in those 3 weeks, I decided that I should do some learning. So the first thing I looked at was blockchain, and taught myself a little bit of Solidity and learned about hash functions and Byzantine generals and all of this stuff. I'm sure a million people understand 1,000,000 times better than me. And I thought blockchain was intellectually incredibly interesting, but I couldn't see any practical applications for it. I didn't see a way of speeding up things in the real human world. I know that might be a thesis that people disagree with, but I'm right and you're wrong. And the next thing I looked at the Internet of Things. I bought myself a little Arduino electronics kit, But I realised, and I thought that was genuinely going to change the world. But in things like agriculture and manufacturing that I didn't really know anything about. Plus, it turned out from the first presentation that there were some people who could do much, much, much smarter things than me. I could turn an LED light on and off from the internet, and I thought I was pretty hot stuff. But it looks like it's a bit more. And then a friend of mine, Andrew Cowie, he works for Google's DeepMind. He phoned me up and he said, Sean, I know you're bored. You should look at these things called large language models. We've got one, and OpenAI have got one. And they're incredible. They can write stuff. They're doing things that you argued for 20 years a computer would never be able to do. And I said, no, of course they can't. Don't be stupid. But I thought I'd have a look at them. And I was blown away, and the word magical is being used. So the next thing I want to focus on is why was I blown away, and why are people blown away the first time they see this, I think. And I think it's because we're really, really used to computers being able to add up faster than us. Like, we don't really mind that. That doesn't really threaten our humanity, that computers can add up faster than us. But the fact that they can write and create concepts and create pictures faster than us, that's pretty scary, and they've never been able to do that before. So the first question I asked myself was, what happened? Right? They can't write, and now they can. That is a pretty big change. And three things happened, and it needed all three of them. So the first thing was that they got bigger. So you can see here's the evolution of the size of these large language models. You're all, I know, kind of deep science backgrounds in this room, so I don't need to tell you that the y-axis is a logarithmic axis. I insist on my scientists never using logarithmic axes because I think they're very bad for communication to normal audiences, but they ignore me and insist on putting logarithmic axes. But that's obviously kind of going up actually with exponential growth in terms of the size and scale of these things. So they got bigger. So computers couldn't write, now they can. Reason one, they got bigger. Reason two, they read more. And modern large language models have read 700 billion words. A human trying to do the same thing would take 23,000 years to achieve the same feat. And again, you can see, again, and it's a logarithmic scale on the x-axis there, these large language models and the scale of what they've read. Though, unfortunately, they've now read everything. There's nothing left to read. If you look at what OpenAI are doing with things like Whisper, some of the thinking there is the reason they're trying to do video to text and speech to text is to try and get more training data for the large language models, because there's just no more training data to be had. And the third thing, and as important as both of those other ideas, was this new idea. So the structure of the neural network, the way that the way that the computer's looking at this, you need a notion of attention. So we propose a new simple network architecture, the transformer, based solely on attention mechanisms. And again, you can see that people were saying that Google was falling behind in this race. You can see that the kind of very large part of the research that made large language models possible is done obviously kind of primarily with Google researchers. What's attention? Well, it turns out if you're trying to work out what the next word should be in a sentence, so if you say the King of France was playing football and fell over and broke their leg and it hurt a lot, it turns out that the start of that sentence is incredibly important, right? Because you know, who is it whose leg is hurting a lot? It's the King of France. And you know, typically in regression models, as you get further along, the start data doesn't matter as much. But in language, it turns out the things at the start of the sentence or the start of the paragraph or the start of the narrative might be incredibly important to what you're trying to pick might happen next. So what can large language models do now? So some of the really cool stuff, extraction and repurposing. So did this a couple of days ago. War and Peace is 500,000 words long. Who's read War and Peace? Okay. Who's actually read War and Peace? So you don't need to, now you can go to dinner parties and pretend you have. So you can get large language models to do this. So we extracted this in a minute, and we just asked it for 9 lessons that a chief executive could learn from War and Peace. And again, its ability to go through vast quantities of text and extract themes or extract information for you is really quite remarkable. Ideation and first draft production. So writing is a fundamentally human activity, but it's quite slow. In our own area, about $500 million, that should be dollars rather than pounds, a year is spent globally writing bids, tenders, and proposals. So, this kind of, I'm not going to argue about whether kind of competition is a good thing or a bad thing, but if you're going to have competition, then the costs of competition you want to make as low as possible, right, in order to get the benefits of competition, but with as low as costs. $500 billion spent persuading the person who's buying your services or might buy your services by writing out why you're the best person to do it. That's clearly a cost of competition that you'd want to try and reduce as much as you possibly could. And then we get to what do speed improvements look like here? So you've got, a human alone might be able to write 500 words of professional prose an hour. With ChatGPT for professional prose, you might get up to 700 words an hour. And then with a specific piece of software like ours, for example, when you're doing a very specific writing task and you've got something optimized for that writing task you're trying to do, you can see again you start to get those orders of magnitude speed improvements. So there are, though, some considerable limitations to large language models. First is repetition, and you can quite quickly get them into loops. They're not saying anything really novel or interesting. The second is what we used to call the Boris Johnson problem, people now call hallucination, but when we first started looking at this. Now, the Boris Johnson problem is that large language models are very, very good at sounding very confident and giving a superficially top-level argument that sounds like it's good, but actually it turns out that what it's saying is completely untrue and has no basis in reality. I'm not sure why we called it the Boris Johnson problem. I can't remember. So one of my favourite things actually to do with large language models and with our software is I will ask it to write an essay, a 3,000-word essay, on how the Darjeeling tea harvest, I'm a big fan of tea, how the Darjeeling tea harvest affects the speed of light. And it writes it's a beautiful essay, 3,000 words, compelling, interesting, but now I am not a physicist, but I'm pretty sure the Darjeeling tea harvest doesn't affect the speed of light. Although the essay will give you all sorts of reasons why it does, and gravitational fields, and it's really impressive. I'm pretty sure it's not going to stand up to experimental test. So they just make stuff up. And then judgment. And judgment is related to the Boris Johnson problem. But you see this a lot when people publish, like in the field of art, they'll publish, look at this amazing image, which I've produced with Midjourney, whatever it might be. But of course, what they've actually done is they've produced 20 images, and 18 of them were rubbish. Right? And you've got this human judgment is able to know what's good and what's bad. So I'm going to suggest it's not clear to me how these problems are going to be solved using large language models. In fact, I don't think they are. There's nothing left for the large language models to read. Right? So they're not going to get any better because they've read anymore. And the scale improvements, in terms of them getting larger and larger, are rapidly dwindling. So what does this mean for the future? Well, I'm going to start with the fact that generative AI makes things up is a feature, not a bug. It's a tiny percentage of the language that we use is about communicating scientifically verifiable propositions. And using a large language model to try and put across scientifically verifiable propositions is a bit like using a calculator to write a poem. It's just a terrible use case for generative AI. So where you do have use cases where truth is important, for example, in our business, you need to couple then generative AI to a reference library. So it wasn't clear at all to me why people were using large language models to do internet search. But it is interesting to do internet search and then repurpose what you found using search using a large language model. Two is that generative AI will not replace humans in every technological advance ever. It's the robots are going to take our jobs, they're going to kill us. But then it turns out that they don't kill us, they don't take our jobs, they just actually move humans onwards. And it turns out that for virtually every technology ever, right, it's a tool that we start to use. And then I'm going to suggest that the most important advances in large language models are going to come at the application layer, that there aren't new powers to be found. and that the underlying models are going to become heavily commoditized. Lots and lots of people are going to be building these models, and the interesting bit will be how you plug into them. Electricity itself, well, is kind of intellectually interesting. The plug-on socket on your wall doesn't do anything. You have to plug a tool into it to be able to then use electricity to do something interesting and human. I'm going to stop there because I'm 15 seconds over. Thank you.
First of all, thank you. Super fascinating, and clearly we all need to hang out more at Google DeepMind, I suppose, among other things. So, so it's interesting that because I remember seeing a tweet from, is it Mustafa Suleyman, that was one of the founders of DeepMind, talking about that ultimately that this is just the beginning of large language models and of generative AI. But you seem to suggest we're actually at the end, if you will, of the Moore's law of generative AI, in the sense that there's nothing left to consume to inform the models. Is that did I hear that correctly?
Yeah, look, I mean, mine is a philosophical position, not a technological one, and there are people who are much, much more able to talk to this technologically. Again, I would come from a evaluating historical sources point of view.
Yeah.
If I were working for a business which was, and had to raise billions to do deep research in a complex, risky area, I'd certainly be telling people that there was a long way still to go.
Right, okay. Right. Okay. We'll talk about there's another talk later about the conflicted interests of AI forecasters. But anyways, I mean, obviously one of the biggest topics has been about job destruction, and particularly on generative AI, much less, if you will, the other AI or the AGI, if you will. I mean, what strikes me is that basically, in the same way that people used to operate slide rules and you have to dig ditches and things like that, that this is going to destroy the jobs that nobody wants to do. Or I mean, that large. I mean, you talked about. I didn't realize the figure was that massive. Thankfully for you, it is $500 billion just in people writing bids and this grant applications and this sort of thing, if you will. I'm sure the academics will feel your pain there. So it seems largely like a liberation, not a destruction.
Yeah, look, I 100% agree with that. Look, and I'm not underestimating when technological change happens, there is a role for society, government, and lawmakers to help the people who are immediately affected by that change make a transition. And I think that's super important. And I think the people who are benefiting from that transition should be a large part of that process and should be forced to contribute to that, process. So in the short term, of course, you get this destruction and there are winners and losers. But in the long run, with every technology we've ever seen as humans, it actually just elevates us humans. It pushes us up the cognitive hierarchy. We get to do more interesting, more fulfilling work. And this technology will be no different to that.
Okay. So, although some argue that, yes, fine, so large language models are going to destroy humanity, but this is the first glimpse after so many years of sci-fi previews of what the AI future might be like, that we're now seeing it live. People can go ahead and enter their own queries and see the stuff that we've seen, sort of thing. I guess, do you buy into the argument that that this is just a glimpse of what's to come, and that while LLMs might not be bad, that there's obviously governments now are convening to discuss about whether or not AI is about to destroy humanity. Any thoughts on whether we're done?
Yeah, it's so look, I can't talk to the wider field. I can talk to large language models, and I've explained why I don't think that they're going to get
very well advised by your PR people
to robot level sort of destructive intelligence. Look, I think again, and I'd come back to the AI companies raising money type piece. Look, it's not clear to me that there is any path whatsoever from the current state we are in artificial intelligence to even a limited form of artificial general intelligence, let alone a kind of super intelligence. There is simply no roadmap there, and the current technology, large language models, which clearly have this emergent property which was magical and transformative, but I don't see any road from there to AGI. And then you're back into the realm of, well, we're going to make a conceptual leap which will get us to AGI. Well, you can say we're going to make a conceptual leap which will get us there, but people have been saying we'll make that conceptual leap for literally centuries. So look, I think this is a really interesting technology because it is both overhyped and underhyped. That's a really interesting place to be. It's gonna transform such swathes of kind of humanity, but not in the killer robots way.
Right.
So it's kind of so it will change everything, but it won't change everything like that.
Right. Sean, thank you so much.
Pleasure.
Cheers, man.